Hello viewers, welcome back to my online tutorials. Recently I started a new video series on Docker. So this is my fifth video on Docker. In this video we are going to see the integration between .NET Core and Kafka services. The video is going to be amazing. It's going to cover a lot of interesting topics. So please watch the video till the end. So as I mentioned, all my sessions are real-time oriented. So in this series also, you're going to see every video hands-on the implementation. So very informative. So please watch, subscribe, and share the videos, and let me know your feedback. So what are the facts about the integration between .NET and Kafka? What is going to happen if you are using the combination of .NET Core and Kafka? So integrating Apache Kafka with .NET Core allows for high throughput asynchronous event streaming in microservices and distributed systems. The industry standard for this integration is the Confluent Kafka NuGet package, a high performance wrapper around the library Kafka. So the implementation patterns are going to be producing messages and consuming messages. So yeah, in short, Kafka is a reliable tool which will handle high throughput for asynchronous events, a streaming of events, a continuous streaming of events, and even the .NET Core applications, they are capable of doing processing multiple uh, continuous streaming of events. So the combination is going to do a magic. So as part of this, we are going to see how we produce a message from .NET Core and submit it to the Kafka topic, and also like how to consume the message from the Kafka topic by using the .NET Core. So if you are working on a high streaming application, like where continuous streaming of information, uh, even million events per seconds it's generating, and if you want to process it, the combination of .NET Core and Kafka will be best suits. Like example, like with the Facebook or YouTube or any uh, entertainment channel, like where continuous events will be generated, and if you are trying to process them, not only the entertainment, if you are in the back end, if multiple events are getting generated, it can be a insurance system where it's generating millions of events per seconds, and if you want to process them within no time, then the .NET Core and Kafka will be best combination. So Kafka is able to process a flood of streaming messages, and also .NET Core asynchronous programming allow you to process them. So simple steps, first create and configure Kafka in Docker. I already covered those detailed steps in this video series. So this is the link. I'll paste this link in the description of this video. So by following this video, you can configure the Kafka in your Docker. Then we are going to see how to create a console application, then installing Confluent Kafka. And once you install the Confluent Kafka in your .NET Core, you'll be able to read and write messages to Kafka topic. And also we will see like various features in the Kafka, like partition, what is the key for a Kafka message, and how we are going to generate the messages. All that step-by-step events we are going to see. So the video is going to be very informative and very interesting. Please watch the video till the end. So first create a .NET Core console application by using a command. So .NET new, I'm going to use the console application because my main purpose is like how to um, um, see how to write the code to read the Kafka and write the Kafka. So to make it simple, I'm using the console application, Kafka console app. So once you create the console application, it created a folder and it created the application here. So navigate to this folder and then add a package .NET add package. So Fluent dot Kafka. So this is going to add Confluent dot Kafka, which is the library for enabling your .NET Core application uh, to integrate with the Kafka. So once it's completed, then you can open the Visual Studio. Open the Visual Studio. So this is the Kafka console app which I just now created. Go to the dependencies, packages. You can see Confluent Kafka and the version 2.14. Now we are going to write the code. So before that, let me show my Kafka topic. Yep, this is my Kafka image, and this is my Kafka container. If you want to see how to configure this, please watch my previous video. And now this is the Kafka UI. Even I have shown how to configure the Kafka UI. So here I'm going to create a topic and I'll name it as test underscore topic. And now I use two partitions and I'll show how the messages will be like distributed to multiple partitions. And I'm going to create the topic and this is the topic. Right now the messages are none. And you can see, yeah, there is nothing, but this is the topic. And there are no consumers, the statistics, everything you can, these are the different tabs. So let's go to the .NET side and add some code. So on .NET side, I'm going to add a model here. So generally, if you're working on um, enterprise applications, like adding the model will make the consistency and it will easy for referring the data. So I'll name it as a product uh, product.cs. So these are the properties. So it's a simple .NET model which contains ID, name, and price. So let's write the code. Straight away, I'm going to write the code for how to first produce the Kafka message. So first config equal to new producer config. Um, so yeah, so this producer config and bootstrap servers, all your Kafka. So here, if you see, I configured the local Kafka in 1992. So that's why in the producer config in the bootstrap server, I gave localhost 1992. That means it's trying to access this Kafka instance. Then using var producer. So we no need to write a lot of code because of the AI and all. It is suggesting the code. So using var producer, new producer builder. So this will tell where we are writing. So we can say Kafka instance here, Kafka instance, and this will tell what kind of message we are trying to produce. So here I'm going to use string. So that means the key, the first one is the key and the second one is the message. So in your Kafka UI, if you see messages, here key, partition, offset, timestamp, and its value. So key and value. So when you're initializing the producer builder, the first parameter is the key and the second parameter is the actual message. And we are passing the config. So this localhost, and we are even initializing we are constructing the producer. And here we are trying to produce the message, the actual message. So where message equal to new. If you are not writing a complex message, just you can say test message. But since we are using the model, we need to initialize the model. No new product. So new product. Yeah. So new product ID GUID. I'm generating the GUID. So I'll say laptop, and this will be 999.99M. So this is the part what I'm trying to write. This information I'm going to write it to Kafka, but I cannot write the C# class into the Kafka. So I have to convert this into JSON. JSON message. So this is serializing. The C# product class, it's going to serialize into uh, uh, JSON serialization, and the value of the JSON serialization, this JSON message will contain this instance. Then I don't know, it generated by AI. So let's remove that. And then where result equal to await producer dot produce asynchronously. So here uh, instead of saying this, you can just drill down this. So await producer dot producers asynchronously, and here you can give the test topic, which is our Kafka topic name. So we are trying to write into this Kafka topic, and this is the message. So the key will be the ID and value will be the JSON message. So now even we defined what we are going to write into the Kafka. So this will generate the message to this Kafka topic, um, this key and this message, and just write something console.writeLine message sent to partition. So here you can get the partition result. Uh, it will the result object will contain which partition it's going to write, and which offset, what is the offset. So finally here you define the catch if something goes wrong. So in simple, we are done with how to produce a message to Kafka. Just revisit. I created a config. So this is pretty much what server you are using. So it's a localhost 1992. Then I'm defining the producer object. So what is the type of the producer? Like string means um, uh, key and its value. So if you keep it null, uh, here you have to keep it null. And this will be null. But I want to generate a key so that that can be used later. And then this is the message I'm trying to generate, the converted into JSON message. And finally, this is going to produce a message to the Kafka. And here we are retrieving the information after it successfully produced. So let's run the code and see. Before that, there are no messages here. You can just refresh. The messages are none. Now run this code and see the messages. Only one message will be generated now. So it's right, taking a bit for the first time. Yeah, so it's, this is the JSON, this is the C# message, this is the JSON message. So if you see, JSON message is a string, like uh, it's it's in this format. So this I can submit, I can produce it to Kafka. And here, this is producing the message. And once it produced, come here and just refresh. See, the offset is 0. The offset will start from 0, and the partition. So the message which I generated, which I produced, it submitted to the partition 1. And this is the timestamp, and this is the key for this Kafka message, and this is the actual message. So I use the same GUID for the key as well as the message. So let's um, understand the result variable. So let's understand the result variable. So if you see the result, you can expand this. What is the key? What is the message? What is the offset value? So for which partition this message submitted? What is the timestamp? What is the topic name? What is the topic partition? Yeah, so this is the complete message. So we successfully produced a message to Kafka. Let's see how to consume the message. So let's define the consumer details. So where consumer config. So consumer config, the producer config is little different. Just bootstrap servers is enough. But for the consumer config, you have to give the bootstrap server, the group ID, which is the test group, or the you can give some group ID, and auto offset the earliest. That means if it's finding multiple messages, it's going to consume the latest message from the um, topic. So this is consumer config, and then define the consumer itself, the consumer object. So the consumer, where consumer, new consumer builder. So I'm again using the same string and string, or you can use the ignore also. So here I'm going to use the ignore, but it's going to read the string value. Then consumer dot subscribe the test topic name. Which topic it's going to subscribe is the test topic. So here I'm going to use the while loop. So while if it is true, so what I'm going to do, where consumer result equal to consumer dot consume. So this will consume the particular message. And after that, you can again deserialize. So from the product, we serialize the message, and now from the message, Kafka message, we are deserializing. So product system dot deserialization into product type, um, which is nothing but the value. So this one, this particular object, the value. Again, we are deserializing, and we can read the information however we want. So let's run this code and see. So run this code again. Again, it's going to submit one more message. So going to produce one more message. So just to distinguish, okay, so the GUID will be different. So based on that, we can distinguish. Yeah, so yeah, let's distinguish them. It's going to create one more message. Uh, so let's see whether do we have how many messages. Um, See, again, the offset, it increases. So it's writing to partition one, but you can have sometimes it writes to partition two. In multi server environments, you will have multiple partitions. So if so the advantage with Kafka, you can operate, you can inject, you can produce messages to multiple partitions, and multiple services can listen to multiple partitions. So to optimize the performance, you can do this. So it again it wrote to the partition 0, and this is the message, and this is the key, and this is the value. Now let's see how it's reading or how it's consuming the messages in this part. So it's the consumer config got created, and the consumer object got created, and it's going to consume the test topic. So while it is true means when there is no end of file, that means when the messages are gone, all the messages are gone, then the while loop will be false. So it's going to consume the message console, and yeah, so then it will it read two messages if you see. So this part we are consuming the messages. Yeah, I executed third time, and you can see it it produced message to the partition two. I have only two partitions. So based on the availability, it switch. If the partition one is um, has two messages to process, then the algorithm it redirect messages to the other partition, and it will balance the performance. So it's amazing. Just now we are done with our first .NET Core and Kafka integration video. So in this video, we have seen how to configure the Kafka. If you want the detailed steps for how to configure the Kafka in Docker, please watch my previous videos. And we have seen how to install Kafka package in .NET Core, which is confluent.kafka, then how the producer and consumer config will be created, and what are the properties when you are trying to create, and then how to create the producer, and how to build the producer and consumer pipelines to connect to Kafka. And then we have seen how to serialize and deserialize the data, which is important, converting model into JSON format and JSON into model format. And finally, we produced messages to Kafka using .NET Core. Um, Thank you so much for watching my videos. Please like, share, and subscribe. Also, provide your comments in the feedback. And let me know if you need any specific topic. I'll try to make the video. Yeah, thanks for watching. Again, happy coding.